How can we shield Mars colonists from radiation? Have you ever wondered how we can protect future Mars colonists from the dangers of radiation? Mars presents unique challenges due to its lack of a global magnetic field and a thin atmosphere. This means that cosmic rays and solar particle radiation can pose serious health risks to anyone living there. Let's break down some effective strategies that scientists and engineers are considering to keep colonists safe. One of the simplest methods is using Martian soil, known as regolith. This dense material is abundant on Mars and can be used to cover habitats. Research suggests that a layer of regolith over 2 meters thick can significantly block harmful radiation. If we use denser materials like concrete, we can reduce the thickness needed by about 40%. Early settlers might even stack sandbags filled with local soil on habitat roofs for extra protection, although this requires careful handling during construction. Another promising approach involves using materials rich in hydrogen. Hydrogen atoms are excellent at blocking particle radiation because they are similar in size to protons and neutrons, which are the main components of cosmic rays. Water is a great example of a hydrogen-rich material. Not only is it essential for life support, but it can also be stored around living quarters to act as a radiation shield. Engineers are even looking into converting waste from astronauts into plastic tiles to reinforce habitat walls, combining waste management with radiation protection. Building habitats underground is another effective strategy. By constructing shelters below the Martian surface, we can take advantage of the natural shielding provided by the soil and rock overhead. This method can drastically reduce radiation exposure, but it does come with challenges related to excavation and construction on Mars. There are also theoretical concepts for creating artificial magnetic fields around habitats. This would mimic Earth's magnetosphere and help deflect charged particles away from living spaces. However, this approach requires a significant amount of energy and advanced technology that is not yet feasible for Mars missions. Additionally, researchers are exploring pharmaceutical options. There are ongoing studies into medications that could protect human cells from radiation damage or enhance the body's ability to repair itself. While these drugs would not replace physical shielding, they could help reduce health risks associated with unavoidable radiation exposure. Practical considerations are also important. Adding mass to spacecraft or habitats increases launch costs, so using local resources like regolith and water is preferred. A combination of shielding strategies, such as thick regolith coverage, hydrogen-rich materials, and underground habitats, can optimize protection while managing costs and logistics. In summary, shielding Mars colonists from radiation will likely involve a mix of using regolith, hydrogen-rich materials, underground habitats, and possibly pharmaceutical aids. These methods aim to create a safer environment for humans to live and work on Mars for extended periods.